Hello everyone, I am going to start class 11 with a new topic that is called dimension, and this topic is first chapter of class 11 under the chapter of unit and measurement. Actually this dimension topic is in the last part of first chapter, but we will start this dimension part in the beginning itself. Dimensions. Before we delve into dimension and dimensional formula, let's discuss about fundamental physical quantities and their symbols and SI units. How many fundamental physical quantities are there? Basically, there are 7 fundamental physical quantities. What is the meaning of fundamental physical quantity? Fundamental physical quantities are the quantities. Those are independent of any other quantity. They are 7 in numbers and their names are luminous intensity, length, mass, time, temperature, electric current, luminous intensity, amount of substance. These are the 7 fundamental physical quantities. Their symbols are these are the symbols. For length we use capital L, mass capital M, time capital T, temperature capital K, electric current I, luminous intensity CD, amount of substance mol mole. And their SI units are meter, kilogram, second, Kelvin. For electric current, SI unit is ampere. CD for candela. MOL, mole, amount of substance, mole. Now I am writing the dimensional formula. In order to represent any physical quantity in its dimensional expression, we use a bracket. For length, we write capital L closed in a bracket. Mass, dimensional formula of time, dimensional formula of temperature, dimensional formula of current. Now dimensional formula of luminous intensity and dimensional formula of amount of substance, mole. So these are the dimensional formula of different physical, fundamental physical quantity. Let me repeat it again. For length we use capital M, mass capital M, time capital T, temperature A, luminous intensity CD, amount of substance mol, mole, closed in a bracket. These brackets represent the dimensional expression of any physical quantity. Now let's discuss some basics related to the dimensional expression of any physical quantity. First is area. Area is basically a square of length. If we are given a square of a side, so its area will be a square, and these both length and breadth are the lengths only. So you can say or side square. So this can be written as L square. Next is volume. Volume means length into breadth into height. Actually, all these three physical quantities are basically lengths. So I'm writing them as length multiplied by length multiplied by length. So the dimensional formula of volume is L cube. Third is density. Density means mass upon volume. So mass, dimensional symbol of mass is m, and for volume we just calculated L cube. So the dimensional formula of density would be m L minus 3. This is the dimensional formula of density. Next is speed. Speed equals distance upon time. Dimensional formula of distance is basically distance means length and time for t. So dimensional formula will be Lt minus 1. This is the dimensional formula of speed. And if we talk about velocity, velocity is also displacement upon time. Upon time. Displacement is also type of length only. So length upon time, again velocity is going to have same dimensional formula, that is Lt minus 1. So speed or velocity. Both have same dimensional formula. Next is acceleration. Acceleration, that is A, is v minus u divided by t. Rate of change of velocity is called acceleration. So again, velocity out of velocity, we are going to get velocity only. So velocity upon time, delta v upon t. The dimensional formula of velocity is Lt minus 1, and for time, capital T. So dimensional formula of acceleration is Lt minus 1. I think this one is 4th and this one is 5th. Next is force. Force is product of mass and acceleration, ma. So this can be written as dimensional formula of mass m, and dimensional formula of acceleration I have just written Lt minus 2. Minus 1 and minus 1, minus 2. So Lt minus 2. So this is the dimensional formula of force, Mlt minus 2. Next is work. Work, that is W, is equals to force into displacement. D for displacement. Dimensional formula of force is mlt minus 2 and displacement is L. So this becomes ml square t minus 2. This is the dimensional formula of work. Is it visible? Let me clear it. Now it's okay. Next is work and energy, because when we perform work, then energy is consumed. In order to perform a certain amount of work, energy has to be uh, you know energy has to be expended. So that is why energy or work both have same formula. Next would be momentum. Symbol of momentum is P, and this is product of mass into velocity. Dimensional formula of mass is m, and for velocity Lt minus 1. So dimensional formula of momentum is mlt minus 1. Next is impulse. Impulse is I. Symbol of impulse is I. This is force applied for short time. So dimensional formula of impulse will be dimensional formula of force, dimensional formula of time. Dimensional formula of force is mlt minus 2 and of time is t. So this becomes mlt minus 1. This is the dimensional formula of impulse. Next would be, I think, Let me make it very clear in your mind that when I'm writing dimensional formula of different physical quantities, basically probably you might not be aware of the formula that how I got this formula I is equals to f delta t or E is equals to mb. Don't get into that what is the derivation, what is the concept behind happening p is equals to mp. Don't get into that. Just focus on the formula and break them into small break them into fundamental physical quantities, as we have only the symbols for the fundamental physical quantities. Once you break the P is equals to mb into fundamental physical quantities, you have dimensional formula also. So you can directly calculate the dimensional formula of any given physical quantity. That probably you may not aware of the derivation part of that, but that's not our business. As of now, just I am teaching you how to derive the dimensional formula. Let's get into that only. Not don't go for the derivation part. That we will understand in the next chapter. Concept related to impulse and momentum and all the other things. As of now, just let's concentrate on the dimensional part only. Next thing is conversion of units. See, you should ask you what is the utility or what is the application of dimensional formula. So let me teach you the applications. So basically there are three applications in our syllabus where we can apply dimensional formula. So application of dimensional formula. First application is in conversion of units. In conversion of units, we use dimensional formula. See, conversion of units is basically based on the fact that the quantity remains same in two different units. Let's say I'm writing 1 kilometer. So basically it can be written as 1000 meter also. Quantities are same. 1 kilometer and 1000 meter both are same. So quantity, that is capital Q, is same. So this conversion of units through dimensional formula can be achieved 1 kilometer in 1000 meters. Let's say this one is n1 and kilometer is u1, and this one is n2 and this one is u2. n1 n2 are the numeric values. Whereas u1 and u2 are the units. Our question will be something like this: convert 1 joule into arc. 1 joule into arc. So basically question is how many arcs are in 1 joule? So let's solve this question in order to understand the concept. Let me make it more clear in your mind first. If you compare this with this n1 u1 n2 u2, there you can draw this n1 u1 n2 u2. n1 is 1 and u1 is joule, whereas n2 is unknown but u2 is arc. So in order to find out N2, we will have to write, wait, from here only, in order to find N2, we can directly write N2 equals N1 times U1 divided by U2. This is our basic formula that we will be using throughout the conversion of units type of questions. So our question is convert 1 joule into arcs. This is our question. Formula is N2 is equals to N1 times U1 by U2. First of all, find out joule means, what is the meaning of joule? Joule is basically SI unit of work or energy. Let's write out the dimensional formula of work, that is ml square T minus 2. These powers will be known as A, B and C. A, B, C. Value of A is m power. M power is 1 and B is L power, that is 2, and C is T power minus 2. So these are the things that we will use in deriving the value of N2. So N2 is equals to N1. Let's write, as joule is just related to mass, length and time, so M1 by M2 power A, L1 by L2 power B, T1 by T2 power C. Now let's replace the values. Our task is to convert SI unit to CGS. So M1 means, M1 is related subjected to U1. So here we will have to write kilo. And here is grams power A. On the place of L1, meter, and here is centimeter power B. Seconds, seconds power C. Now let's see, we will have to convert from SI to CGS. So this means kg meter should not be visible. So let's convert kg into grams. And 1 gram. 1 kg is equals to 1000 grams. A means 1. 1 meter is equals 100 centimeter. Power B means 2. Second to second cancel. 1 power anything is 1. Is it visible? Yes. So value of N2 is, let's replace the value of N1 also. N1 is 1. Gram to gram cancel, centimeter to centimeter cancel. So this one is 10 power 3 power 1. And this one is 10 power 2, 10 power 2 power 2. So N2 is equals to 10 power 3 multiplied by 10 power 4. So N2 equals 10 power 4 plus 3, 7. So that means 1 joule equals 10 power 7 arc. 10 power 7 arc. This is the answer. Let me give you another example. Let me first erase it. Next question is, convert 1 Newton into dyne. Newton is unit of SI unit of force, and dyne is CGS unit of force. Both are SI and CGS units of force. So first we will have to write Newton is SI unit of force, and dimensional formula of force is MLT minus 2. Let's find out the values of A, B and C. A means M power 1, B means L power again 1, C means T power, that is minus 2. Let's keep them aside. Now next is, what is the formula? N2 is equals to N1 M1 divided by M2 power A, L1 divided by L2 power B, T1 divided by T2 power C. This is N1, U1, N2 is unknown, and this one is U2. So let's replace their values, substitute the value of N1, N1 is 1. Mass, we will have to change SI to CGS. So mass means M1 is in kg upon grams. A means 1. Next is length, means meter upon centimeter. Power B again 1. Second upon second. Power minus 2. That is again second by second is equals to 1. Power whatever again makes 1. So let's convert kg to gram. So 1000 grams means 1 kg. Power 1. I am not writing that. 100 divided 100 centimeter upon the centimeter. Gram to gram cancel, centimeter to centimeter cancel. So I am getting N2 is equals to N2 equals 10 power 3 multiplied by 10 power 2. That is 10 power 5. This is the value of N2. That means 1 Newton equals 10 power 5 dyne. So this is how we will do the conversion of units. This is the answer. Next question is, let me read it first. Next question is, convert G, that is universal gravitational constant, whose value is 6.67 10 to the power minus 11 Newton meter square per kg square, to CGS, that is 9 centimeter square per gram square. So what we are given? We are given N1 U1 and we are not given N2, that is unknown, and we are also given U2. So our formula is, let's find out first the dimension of G. Dimension of G. In order to find out the dimension, because we have the formula of universal formula of gravitational force, that is F is equals to G times M1 M2 divided by R square. So G becomes F R square divided by M1 M2. So the dimensional formula will become, first let's write out dimensional formula. You will have to first split all the physical quantities like force, radius, mass and mass. First write the dimensional formula of force, then radius, then mass. So dimensional formula of force is M L T minus 2 into radius square, means length square, divided by mass into mass, means M square. So the dimensional formula of G is M power minus 1 L cube and T power minus 2. This is the dimensional formula of G. Once the dimensional formula G is known, that means G only depends on mass, length and time. So that means value of A, B and C can also be found out. A, B and C. A is M power minus 1. B is L power and T is C. C is T power. M power, L power, T power. A, B, C. Now let's convert this from SI to CGS. So let's apply the formula N1 multiplied by M1 divided by M2 power A, L1 divided by L2 power B, T1 divided by T2 power C. Is it visible? Yes. I am not writing the value of N1 again as it is really very big. So I am just using N1. So N1 mass means kg. What is the value of A? Minus 1. Substitute the values very carefully, otherwise your answer would be wrong. L1 means meter, centimeter. What is the value of B? That's 3. Second by second power minus 2. Again, this one is 1. So N1 kg means 1000 grams by gram power minus 1 into 100 centimeter upon centimeter power 3. Gram to gram cancel, centimeter to centimeter cancel. So that becomes N1 times 10 power 3 and 10 power minus 1 also. And this one is 10 power 2 and power 3. So this becomes N1 times 10 power minus 3 multiplied by 10 power 6. Is it visible? Okay. So N1 becomes sorry, N2. N2 is equals to N1 times into 10 to the power minus 3 plus 6 is plus 3. So let's substitute the value of N1. Here is the N1. So that is 6.6710 to the power minus 11 multiplied by 10 power 3. So 6.67 10 to the power minus 8 dyne centimeter square per gram square. So that is the value of N. This is our answer.